Today, we're diving into the 10 most important robots ever sent to space. But these aren't just explorers. No, they're the architects of our entire future beyond Earth. And the story of how we got here, well, it starts with a leap in ambition that is just mind-blowing. Let's get right into it. Okay, so picture this. Right now, on Mars, the Perseverance rover is hard at work. It weighs over 1,000 kilograms. It's a nuclear-powered, laser-equipped, one-ton geology lab on wheels, hunting for clues of ancient life. But the very first robot we ever sent to drive on another planet, it was a completely different story. Just 10.6 kilograms. You heard that right. The Sojourner rover, which landed back in 1997, weighed less than a car tire. That insane jump in size and complexity tells you everything you need to know about how serious we've gotten about working in the most hostile environment we can imagine. Because, let's be honest, that's exactly what space is, an impossible arena. We're talking lethal radiation that just fries electronics, temperature swings of 300 degrees Celsius that can shatter solid metal, and absolutely, positively zero chance for a repair guy to come out. Every single robot on this list is an engineering miracle, built not just to survive, but to succeed against all odds. So let's kick things off with the pioneers. These are the robots we send out as our eyes and hands, to touch, taste, and see the surfaces of other worlds, charting the great unknown for all of us back here. Kicking us off at number 1, the Mars Rover. Now you gotta understand, this machine is basically an autonomous geologist, working millions of kilometers from home. Because of that insane distance, there's a huge communication delay, so if it hits a snag, it has to solve it all by itself. A round-trip message to Earth for help would take a full 44 minutes. It's literally our robotic self on another planet. But wait until you hear about number 2, the Lunar Rover. For this robot, the biggest enemy isn't distance. It's the place itself. It has to survive lunar nights that plummet to minus 173 degrees Celsius and operate in this abrasive, razor-sharp moon dust that just shreds machinery. Its mission is absolutely vital. Find the water ice that will one day let us build a permanent human base on the moon. Now this next one completely changes the game. At number 3, we have the Sample Return Robot. Think of it as the ultimate interplanetary courier. It has to land itself on an asteroid, grab a perfect, uncontaminated sample, and then get this, launch itself on a multi-year journey all the way back to Earth with zero human help. That is a round trip across millions of kilometers, totally on its own. Coming in at number 4 is the Deep Space Probe. These machines are engineered to last for over 50 years. They are humanity's furthest reach, our interstellar messengers. Probes like Voyager are still talking to us after decades, traveling billions of kilometers from home, all powered by what are essentially long-lasting nuclear batteries called RTGs. So we've sent these incredible explorers out to the far corners of our solar system. But what about right here at home? Who are the unsung heroes taking care of the critical infrastructure that's just a few hundred kilometers over our heads? And that brings us to part 2, the orbital workhorses. These are the machines that build, maintain, and protect the assets our modern world relies on every single day. We'll start this section with an absolute giant. Number 5, the Space Station Robotic Arm. This thing has a payload capacity of 116,000 kilograms. To put that into perspective, this single arm can move things more massive than a fully loaded semi-truck. This is the robot that literally built the International Space Station, piece by massive piece, while flying through orbit. Next up at number 6, we've got the Orbital Mechanic. The satellite servicing robot is a total game changer. You see, before this machine, if a billion-dollar satellite ran out of fuel, it was just space junk. This robot can autonomously meet up with it, refuel it, and even make repairs, saving billions of dollars and extending the life of our most valuable tools in orbit. So if the last robot was the mechanic, then number 7 is the Orbital Janitor. The space debris removal robot has one critical job: hunt down dead satellites and other junk using things like nets and harpoons. And the reason is so important. A single collision up there could set off a catastrophic chain reaction, destroying the orbital highways we depend on for GPS, for communication, for weather. This thing is protecting trillions of dollars of infrastructure. This next one really shows you the crazy potential of space. Number 8 is the Microgravity Manufacturing Robot. This is an orbital factory that can make things that are physically impossible to create down here on Earth. In 0G, you can grow perfect protein crystals for new medicines or make flawless fiber optic cables, literally using the unique environment of space to invent the future right above us. Okay, so we've explored other worlds, and we're managing our own orbit. That leads to the big question. What is the next great leap? What happens when we stop just visiting space and we actually start living there? And that brings us to our final section, Part 3, the extraterrestrial builders. These are by far the most ambitious robots on our list, the machines designed not just to explore, but to actually build our future off-world. Check this out. Number 9 is the Lunar Construction Robot. This machine doesn't need a single brick shipped from Earth. No, it's designed to land on the moon, scoop up the local moon dust, it's called regolith, and use it to 3D print landing pads, radiation shields, and even entire habitats for humans. And finally, we've made it to number 10, the capstone of our list, the Autonomous Orbital Assembly Robot. This is basically a free-flying, dual-armed shipyard in space. Its job is to build structures in orbit, like giant telescopes and spacecraft that are so enormous they could never survive being launched from Earth. This is how the next generation of space megastructures is going to get built. So what's the one thing that connects all of these incredible machines? What's the single thread that runs through a geologist on Mars, a mechanic in orbit, and a 3D printer on the moon? It's this simple. They aren't just one-off science experiments. Every single one of them, in its own way, is laying a brick in the foundation of our multi-planetary future. They are the vanguards, the tool wielders. They're building the essential infrastructure that will finally allow humanity to step beyond our homeworld for good. 10 robots, from 400 kilometers up to 225 million kilometers away. All of them building humanity's future among the stars. If this changed how you see our future in space, do me a favor and hit that like button, and be sure to subscribe for more. In our next explainer, we're coming back down to Earth for something completely different, the incredible world of entertainment and sports robots. Machines built not for work, but for pure wonder. You are not going to want to miss it.
I'm Synera, and I just want to say a huge thank you to every single one of you for spending your time with us today. It genuinely means the world. If you enjoyed this, do me a favor, hit that like button and subscribe so you never miss what we put out next. We've got so much more coming your way, and I can't wait to share it with you. Until next time, stay curious, stay inspired, and I'll see you in the next one.